What we're going to look at now is finding the subgroups of our group of symmetries of an equilateral triangle, and we're going to focus on our proper subgroups. So first off, we're going to use Lagrange's theorem. Okay, so the order of this group is 6. Okay, so we'll say the order of G is equal to 6. Okay, so that's how many elements are in the group. Now, the factors of 6, which are possible subgroup orders, would be 1, 6, 2, and 3. Now remember, 1 and 6 are going to be your improper subgroups, so I'm not interested in them here. We're going to focus on the 2 and the 3. Now 2 and 3 are both prime, so therefore any group of their size is going to be cyclic, so this group is only going to have cyclic subgroups, okay, for their proper subgroups. So we can find them by finding an element of order 2 and generating its powers, okay, and then we could do the same for order of 3. Find an element of order 3, write out its powers, and you'll have yourself your subgroup. Okay, so let's start with 2, okay, and actually thinking back to our video on subgroups, if you want a subgroup of order 2, you need to take the identity and then a self-inverse element, so it'd be E, and our self-inverse elements would be these 3 down here. So we could do E and S1, we could do E and S2, and then finally we could do E and S3. Okay, so that's 2 sorted. Now let's do 3. So let's take one of our elements of order 3. So let's take R1. Okay, and let's write out its power. So R1, the power of 1 is R1. R1 to the power of 2 is going to be R2. And then it has an order of 3. So R1 to the power of 3 is going to be our identity. And then we have our subgroup here. It's E, R1, and R2. Now, I don't need to use R2 to generate a subgroup because it's the inverse of R1, so it will give me the exact same subgroup. Now, in terms of what we can learn from this to speed things up, the identity and a reflection will always be a subgroup. The identity and all the rotations together will also be a subgroup. Okay, they form their own group on their own. Now, there might be other subgroups for larger symmetry groups that have a bit of a mix between our rotations and our reflections. Okay, however, these ones will definitely be subgroups. Okay, and you've got the summary there.